Okay, we'll be starting section 1.4 today. Here's the two learning targets we're going to be working through. I can determine whether relations between two variables are functions or not. There's a couple of different techniques we're going to use to determine that. And then I can evaluate a function for a given expression, sometimes numbers, sometimes expressions. We'll get through these two today, okay? So if you're at home, you're going to have to pause here for a moment because in class they were reading page 35 and filling in these definitions. Okay, I'm going to go over here in just a second, but if you haven't done it yet, pause now and fill them in. Okay, so some things you maybe want to add to this. The domain, for example, is usually always X. If it's an application problem, it might be something like T for time or something like that. But the domain is usually referring to X. It's also called the inputs of the function. Okay, so things you might want to add. And the range typically is Y, unless it's an application. And those are the outputs of the function. All right, some things to maybe emphasize in the definition of a function. And maybe you wrote down this exact same thing from the book, but you're really looking for, each element or every element in the domain has to correspond to just one element in the range, or Y. Okay, each X can only correspond to one Y value. Okay, so as you're about to see here, we're going to see functions represented in a variety of different ways: verbally, numerically, graphically, and algebraically. Equation with two variables, which will be on the next page. Okay, so this next example, the first example, says determine whether the relation below represents Y as a function of X. Justify your answer. Now, once you get used to this, you might be able just to look at the coordinates, look at the definition of a function, and then make a decision. I think it's a good idea, though, especially since so many of you are visual learners, to create a mapping diagram for this. So here's what I mean by that. Go ahead and make a list for the domain. And we're going to make a list for the range. So let's list the set of numbers in the domain. Okay, so that's the X values. So -1, 0, 1, and 2. Okay, if we look to the range, we have 3, 4. 3 happens again. I don't need to write that again. We're just trying to write the set of numbers. 3 is already contained as the set of numbers, so go down to -1. And a mapping diagram kind of maps out each ordered pair. So -1, 3, I want to map it out like this. It shows the relationship of these ordered pairs in this function. 0, 4, 1, 3, and 2, -1. Okay, now, does each X, if we look at this definition, does each X or every X correspond to exactly one element in the range? This X value has exactly one Y value. This X has one Y. This X has one Y. This has one Y. This is fine. They can share the same Y value. Each X has one Y. So yes, each X has one Y value assigned. Okay, because I'm addressing the fact that it says justify your answer. Okay, so yes, it is a function. Okay, you go ahead and try number 2 on your own. Okay, just to relate this to an application real quick, so you're making some sense of this definition of a function. Why does each X need to have one unique Y? If I go back to this sales example from Best Buy, I can't go on to 2011. I'm sorry, yeah. Let's just say I had 2011. Okay, it's okay to have a Y value repeated, 49.7. That's fine. Maybe the sales went back down. But what I can't have is I can't have another data point that says 2009 and a different number of sales, like 60 billion. wait a minute, that doesn't make sense. So each x can only have one y assigned to it, okay? X values, though, can share the same y value. That makes sense. Sales go up and down. That's fine. This would not be okay, all right? So just want to interject that to make some sense of this. So for number 2, the one you just tried, this one doesn't work. Here it is mapped out. Zoom in on this mapping diagram. -2 is assigned -1, and 3, nope. These mapping diagrams are not required. It just helps you see it. So maybe on the order pair you already see it. Fine. So when x equals -2, 2 y values are assigned, not a function. Okay. On the next page, example 3 and 4 are just kind of follow-ups to this. Go ahead and take a look at that now and see if you can come up with an answer for 3 and 4. Okay, there's no reason to say why this is not a function. There's nothing that contradicts the definition. Each x is assigned one y value. We're good. Okay, just the coordinates presented in a table. That's how that one's different. 4, they jumped into a mapping diagram for us already. And clearly we can see when x is 0, we have a problem. It's assigned this y value and this y value. Okay, so no, when x is 0, 2 y values are assigned. Or 2 values are assigned. Okay. Okay, so we're going to basically in this textbook, they don't talk about the vertical line test till section 1.5, but I think it's useful to use now in section 1.4. So on page 50, you can maybe reference this if you want to and jot it down. But I'm going to put this under the camera right now and talk about the vertical line test. Okay. Vertical line test, easy to use. You probably remember it from the past. Basically says that if we can draw a line through a graph and it intersects at 2 spots, then it won't be a function. And it lines up perfectly with what we just talked about. So for example, where they drew this line, this coordinate is like somewhere around 2, -1/2. You can see that. Sorry if you can't. This is 2, -1/2. And then this is, approximately 2 and 2.5. Well, we just looked at order pairs that when x is 2, it can't have 2 different y values. So that's why the vertical line test works good. Okay, now you could draw that anywhere. They just gave you one example. If I can draw this vertical line anywhere, intersects 2 spots, we say it's not a function. If it only passes at 1 spot, we're good. Okay, that's kind of what the vertical line test says. If it intersects at just 1 point, then it will be a function of x. So these two are good. This is a function, this is a function, this is not. Okay, so we'll use that in this next set of problems. Just like this. Okay, before we do it, I want you to write down these steps, the success criteria off to the side. I put steps/strategies. The first step says to solve for y. If it's not already solved for you. Sometimes it is solved for y, but if not, you're going to want to write this in terms of y. All right, and the second step, once we have it solved for y, is we're going to use our prior knowledge from Algebra 1, Algebra 2. Sometimes, though, on some of these functions, our prior knowledge might be limited, and that's okay. So our backup plan is to view the graph in the graphing calculator and apply the vertical line test, VLT. All right. Pause here for a moment and let you copy that down. All right, so let's try it with example 5. It's not solved for y. Well, we can fix that. We're going to take 2x and move it over. Okay, so moving that over gives me y equals -2x plus 8. Okay, this is where prior knowledge should be pretty good for all of us, especially since we've reviewed y equals mx plus b this year and linear functions. Okay, this will work. Okay, but the backup plan is, and I can't quite remember, or it's something that you don't have prior knowledge on, is we're going to just dump this into the graphing calculator. Hit zoom 6 for a good standard window. and then check to see, does this pass the vertical line test? Clearly it does. But that's something you can kind of see in your head, right? And don't have to always check it with a linear function. So yes. So I put yes because it's a linear function. Yes, it's a linear function. And that's kind of what the question asks. I know they kind of asked this a little sophisticated. Determine whether each equation defines y. That's why you should define it for y, right? Solve for y. Defines y as a function of x. Okay. Let's look at 6. Now you might have some prior knowledge of this right away. I'm going to wait, come back and talk about that in a moment. So let's go through the steps of solving for y. So let's move x squared over to get to this step. I already put the square root in there. So basically we'd be writing y squared equals negative x squared plus 16, or if you wrote 16 minus x squared, it's fine. Okay. Now take the square root of both sides, and we get this. Y equals, remember when you manually do the square root, you got to add the plus or minus, even with functions like this and expressions. All right, now our prior knowledge of this function might be a little limited, so you definitely want to resort to the calculator. And here's the trick. To graph this and view this, we have to put them in 2 separate y equals in our calculator. So that's why I tag this as y1. So this would be the positive version of it, right? And then the second line, I'm going to put the negative version of it. I'm addressing the plus minus. Okay, so I'm going to punch these in my calculator, but I'm going to pause while I'm doing that. Okay, so this is how I enter this in. The plus or minus is this way. And when you plug in a negative in your calculator, make sure you use this negative down here, not the minus side, okay? Because sometimes it gives you an error message. All right, so now when I hit zoom 6, let's see what we get. All right, looks like an oval, but it really is a circle. It just, because of the 16 by 9 screen on here, it doesn't pass the vertical line test. This is where your prior knowledge might have kicked in. I don't know if you'd see it or not, but from last section, we know what HK is. It's got to be 0, 0. So this has a center, 0, 0, radius 4. Okay, so maybe we could make that decision right away and use your prior knowledge. It's up to you if you see it or not. All right, so your explanation could be something like that. Not a function, doesn't pass the VLT because we looked at it. Or you could say it's not a function because it's a circle. And circles aren't going to pass the vertical line test. Okay? All right, you guys try 7. And then don't do 8. I'm going to replace 8 with something different here. Okay, so we move the x over, take the square root, and then we got to add the plus or minus. Once again, our prior knowledge is probably going to be a little limited on this the square root function. All right, so we'd have to plug it in like this in 2 separate y equals and take a look at what we see. All right, not going to pass the vertical line test, is it? Looks like one of those graphs on page 50. Okay, each x, we do not have 2 different y values. I'm sorry, we actually do have 2 different y values, and that does not work. So, nope, not a function. It fails VLT. Okay. Not a function, fails the vertical line test. Okay, for 8s, I want to replace that, and I'll show you 2 more little versions that might come up in your OTI, which will, and I'm not in your quiz, so replace it with these 2 right here, please. Scribble out 8. Why don't you call this part A? I've already actually solved both these for y for you already. So y equals x squared minus 6, and part B, y equals negative square root of x plus 4. Notice that is not plus or minus. So give that some thought for about a minute or 2, see what you can come up with, and then we'll go over it.